Good morning, Algebra 1. Hope you guys are doing well on this Monday morning. Hopefully we have school today. Either way, I'm not going to be there, so I want to be with you digitally for a little introduction to Chapter 8. So hopefully you can see my computer screen here with the beginning of Chapter 8 open in your textbook. Section 8.1.1. You get to start chapter 8 today. In terms of getting new table mates, I will let you guys figure that out however it is that you want to. And just work with 2 or 3 other people until I return. So I want to go through a couple of questions with you guys to remind you of what the beginning of chapter 8 is going to be based on. It's going to be based on something that we did back in chapter 3 using generic rectangles to factor expressions. So problems 1 and 2 here in section 8.1.1, which you should be able to find on page 367 of your textbook. Try to get us back into that a little bit. And then, as we'll see, we will move forward factoring expressions and using that as sort of the basis for our study of quadratic functions. So linear is done, exponential is done, quadratic is next. So I have problem 1 copied over here so that I can use it and use my handy dandy little pen here to write down things that I need to. So part A of number 1, which I'd like for you to write down with me, is asking us to take this pile of algebra tiles, which hopefully you remember from chapter 3, and write it as both a product and a sum. So if you recall, a product, the product, the product is going to look something like this, parentheses times parentheses, okay, something like that. And then the sum is just going to be all the things all added together, all right? So if you look at this pile of algebra tiles, remember that the little squares over here are all ones. They have dimensions of 1 times 1. These smaller little sticks are x values or x tiles. So they have dimensions of 1 times x. 1 times x is x, right? This x squared tile has dimensions of x times x. Okay, so x across the bottom and x up the side. And then this xy tile actually has dimensions of y across the bottom and x going up the side. Okay, so as you can see, just by recognizing what these tiles are here across this bottom row and what their dimensions must be, I've already written out the dimensions basically across the bottom, except I've missed that little 1 right there. So if you go through the 4 tiles, 1, 2, 3, 4 that we have in the bottom row, we should be able to recognize that the dimension across the bottom, like the entire base of this big pile of tiles here, the bottom dimension is a y plus an x plus 2 1s, okay, which would give us a total dimension of, and I can put it in parentheses as one of my factors, okay, one of the parts of my product, it's y plus x plus 2. Okay, y plus x plus 2 is the bottom of this pile of tiles, the bottom dimension. Now, the other dimension, right, going up the side, if we think of this like base times height, the height of this pile of tiles is an x right here, and then all of these little sections here, 1, 2, 3, 4, those are all 1s, okay, because they're little skinny guys and they end up making these ones over here. But all of these are 1s, so that this y and this y and this y and this y are all 1 times y from the bottom here, okay? So again, the dimension going up the left-hand side is an x here, and 1, 2, 3, 4 ones. So that would make a total height all the way from the bottom to the top. All of that put together is x plus 4. Okay. And what I've just written right there is the product that they were looking for. Okay. That's the product. It's two sets of dimensions. One is across the bottom and one is up the side. Okay. So again, hopefully that's somewhat familiar from chapter 3. Now, we did not use y's and x's in the same one. And moving forward, we won't really do that either. But this is just an example that our book's giving us here in problem 1. Now, writing it out as a sum is actually, in some cases, much easier. Okay, you just have to look at the tiles. You have to figure out how many of the different types of tiles exist in the square. Okay, so what I notice is starting in the bottom left corner, I have an xy. I have an xy square right down there. Okay, so that one is done. Then next to that, I have an x squared, and I don't see any other x squareds anywhere. So I'm just going to put plus a single x squared. Okay, so that takes care of this guy down here as well. Okay, now if I go across the bottom here, I have an x and another x. Right, I got two x's right there. And then I also have some x's up here, 1, 2, 3, 4 up there. So that makes a grand total of 1, 2, 3, 4, 5, 6 x tiles. So I'm going to add 6 x tiles. And then the other things I see here are some y tiles. I believe there's 4 of those. 4y plus, now I'm just left with my little teeny tiny squares. 1, 2, 2, 3, 4, 5, 6, 7, 8. 8 of those, okay? So then all of that, okay, all of that stuff on the left side is the sum. Okay, writing it out as a sum is all the tiles put together, okay? So writing things as a product of two dimensions and as a sum, which is like a collection of tiles, is a chapter 3 thing that is coming back to us again in chapter 8, okay? Now, I'm going to try to get rid of some of this stuff and then use my own generic rectangle to do letter B, which is, again, meant to be review for us. So hopefully you have that written down. If you don't, pause the video, go back, do what you need to do, get that written down. So if I get rid of some of this stuff, looking at letter B, they want us to go back to another thing that we were actually tested on in chapter 3, which is using a generic rectangle to multiply dimensions together. Okay, so if I take this set of dimensions right there, and I make my generic rectangle, this kind of skill should feel very familiar to us. Okay, so across the bottom, I have 6x minus 1. Going up the side here, I have 3x plus 2. Okay, so again, I'm just taking these two dimensions from part B of that problem, and I'm putting them as the dimensions, base, and height of this generic rectangle that I'm pretending is a pile of algebra tiles. Okay, now to fill in each of these boxes, I simply take the dimensions of the squares of these boxes and multiply them together, right? So the bottom left square here is 3x times 6x. 3 times 6 is 18, and x times x is x squared, okay? 18x squared, 3x times 6x. If I go up to this top left box, I have 6x being multiplied now just by 2. 6x times 2, 6 times 2 would make 12x. Then if I go to the bottom right and get my other x's, I have 3x here on the left, and I have a minus 1 on the bottom. 3x times minus 1 makes minus 3x. Okay? And then up here in the top right corner, I don't have any x's anymore because it's just positive 2 from over here times negative 1 from down there, which is negative 2. Okay? So now if I want to write out the solution as a sum, I take all of these boxes and I just string them out all together. Okay, now 18x squared plus 12x minus 3x minus 2. And then, of course, to find my final answer, I would put those two boxes together. 12x's minus 3x's. So I would get 18x squared plus 9x. 12 minus 3 is 9 minus 2. Okay, so that would be my answer to part B of question 1. Okay, so hopefully that all makes sense, and I will be back shortly with problem 2. Okay, and here is problem 2 from chapter 8, section 1.1 that I'd like to help you through right now as well. It talks in the problem about the process of factoring. Okay, so the process of changing a sum, which you see here in A, B, C, and D, to a product is called factoring. Now, we have been, back in chapter 3, we've been going the other way, right? We've been given a set of dimensions, just like in problem 1, 6x minus 1, 3x plus 2. That's a product, and we've turned it into a sum. And now we're going to be asked to go the other direction. Here we're going to be asked to go backwards. And eventually we will use generic rectangles to do it. But that's something that you guys are going to figure out. I'm going to show you an example here using algebra tiles to factor a sum into a product of 2 dimensions. Okay, so we're going to start here with 2x squared plus 7x plus 6. So this is essentially a pile of algebra tiles, 2x squared tiles, 7x tiles, and 6 individual tiles. So if I click over to this screen, you can see I have a cool little interactive algebra tiles website from your textbook that I have linked on Google Classroom, so you can use this if you'd like. But I'm just going to click and drag out here some algebra tiles that correspond to this expression here, 2x squared plus 7x plus 6. So I have 2x squareds, and now I want 7x's. 1, 2, 3, 4, 5, 6, 7. And then I need 6 individual pieces. So I'll go back to here, and I'll get these unit tiles. 1, 2, 3, 4, 5, 6. Okay. Now, my job is to take this collection of algebra tiles, and I'm going to try to make a rectangle. Okay, I'm going to try to build a rectangle, perfect rectangle, where everything's touching and not breaking any of the rules that we did back in chapter 3 with the algebra tiles, and then I'll try to write down the dimensions. And if I can do that, that is factoring. Okay, so I'm going to try it with this set of algebra tiles. And really what I'm trying to figure out is, can I do it? Can I do it with A? Can I do it with B? Can I do it with C? And so on. All right. So if I take this set of tiles and I try to arrange them all, remember that my typical go-to is to put all the x squareds in the bottom left. And using this cool little thing, they kind of click together like that. Put the x squareds in the bottom left, and then try to rearrange or try to arrange these x tiles along the side and across the top so that they kind of make a nice little rectangle here, and I can fill in all of my unit squares like this. Okay, so I do this. I think this is not going to work out very well for me because this guy, I mean, I guess I could put it down here, but I'm going to end up with 1 extra tile. So this original guess of mine is not going to work. So I think what I have to do is I have to move some of these x's up here to the top. Double clicking them, by the way, is how you get them to change orientation. And then I think I can take this and this and that, and there's my perfect rectangle. Okay, so capture this image in your brain and then try to copy this, or think about, okay, what do I have in this rectangle or in this collection of algebra tiles across the bottom, right? So remember that the dimension across the bottoms here of these x squared tiles is x, and then another x, and then 1, 2, 3. So here, if I was to make a generic rectangle out of this collection of algebra tiles, across the bottom, I have two x's and then three individuals, okay? Because this is 2x squareds, and then this part of my picture there is three x's. So this is three x's, okay? And then going up here, I have four x's, right? But this outside dimension here, going up the top, is an x from the x squared, and then 1, 2 from those little dimensions, okay? So I have, sorry about that. So I have here four x's in this section, and this is an x, and then this is a 2, okay? And then my individual pieces are all in the top right corner, okay? So these 6, if you notice, they're all right there. These 2x squareds are all right there. And then these 7 x's have been broken up, right? They've been split up into 4 x's right there and 3 x's right there. But I've now made a perfect rectangle with that pile of tiles, and the dimensions across the bottom are 2x plus 3, and up the side, x plus 2. And if you were to make a generic rectangle with those dimensions and multiply them, you would get 2x squared plus 7x plus 6. Okay? Now, I'm going to skip to doing part C of this one, and I probably will just skip over the rest for the sake of time. But you kind of get how this is working, hopefully. We're using algebra tiles to try to create piles of tiles and turn sums, like we have in this problem, into products. Okay, if we can take a sum and turn it into a product, that's our goal. So let's see, an x squared, 4 x's, and then 1 individual. Okay, so I can get rid of one of those x squareds. I can get rid of 3 of these x's. Get rid of those, get rid of those, get rid of those. Take some of these 1s and just put them back because I don't need them. I only need 1 unit tile because it ends with a +1 in that expression. So now I have this pile of tiles right here, and I'm going to try to make a perfect rectangle out of them. So I can put a couple of x's up there. I can reorient some this way. But I don't have enough unit tiles to fill in this section up here, right? Like I can put one there, but that's not a perfect rectangle. I can move this one down there, but I still have those 2 blank spaces. And then if I try to put all of them down there now, there's really nowhere for this single guy to go. So let's see. I mean, you can try to get real creative if you want and try to move some things around like that. But still, I don't think I have enough of these unit squares, these dark blue ones, to make a perfect rectangle at all. So what I would say then about this quadratic expression right there, sorry, back to the marker. This one is what we would say is not factorable. Why is it not factorable? And what does that mean? Well, not factorable means I can't break that sum of algebra tiles, that collection of tiles, into nice dimensions like base and height or length and width of a rectangle, because I can't build a perfect rectangle with it. So when we do this, we should recognize now there are going to be some quadratic expressions that look like a pile of algebra tiles that we cannot make a rectangle from, which means we can't get them to be broken up into a product of 2 dimensions like this. It's just not possible for that particular quadratic expression, okay? It is for A, it's not for C, because we just don't have the right pile of tiles, okay? Now, as you guys move forward in this lesson, you're going to get to look at problem 3, okay? And you're going to try to find the sum and product of these generic rectangles here, okay? So they've already done the work for you of kind of like breaking up the pile of tiles into sort of the sections, and they want you to see if you can find the dimensions, bottom and side, and then the total collection of the tiles that are inside, okay? And then number 4 is a really important key piece of information for you to take with you into tomorrow's section. So hopefully this all makes sense. If not, reach out with a question. I'd be happy to get back to you, or rewatch this on slower speed and don't 1.5x me, okay? Anyway, Good luck with problems 3, 4, and 5. And then, yeah, we will see you tomorrow.